Okay, lovies, we're on our last section, and that is the section for spread. So we've covered describing shape, we've covered identifying outliers, we've covered which measure of center to use, and now the last thing that we are going to cover is the spread or the variation in a data set. Now, I prefer the acronym SOCS, but your textbook uses the acronym, there's no acronym, uses the acronym SOCV. And that's why down here under spread, I have the word variation. So spread and variation are the same thing. It just means how varied is your data, like what is the range of your data, how low do the values go and how high do the values go. We care about how spread out a data set is. It actually matters quite a bit. So we must look to see whether all the values are tightly clustered around the center or spread out. So we must look to see whether the values are all clustered in the same area or whether they are much more spread out. So I have some data sets to the side of me, and maybe I can find some that are different. So this data set for the teacher shoes spread out from 0 to 100. That is a very large spread. But this spread for the fourth grade jumpers, the fourth grade kids that have to do the jumping test, this data set actually is not very spread out if we don't consider this outlier. So this is an example of a distribution that is not very spread out, does not have a large spread. This is an example of a distribution that does have a large spread. This distribution that is skewed right also has a very large spread. Very large spread. I'm seeing if I have any that are right next to me that don't have quite as large of a spread. This guy, this is the caffeine and soft drinks. I would not say that this has a large spread. I think that this spread is pretty decent. Most of the data is around this upper 2 stem. So we just want to get used to looking at a distribution and noticing, is it clustered around a value or is it spread out? There are 3 different ways that you can measure spread. So the most basic one is range. How far apart are the 2 extremes? So the formula for this is range equals the max subtract the min. And that does give us helpful information. It tells us how small do my values get and how large do they get. So if we go back to our example of test scores on the last quiz, it would be better if the range of scores was from 70 to 100. That is a very good spread. That data would be considered clustered around some value, but a score of 70 to a score of 100 is an example of range or the min to the max. Now, a very large spread would be something like 40 to 100. And our last quiz did have a spread or a range of 40 to 100. In fact, we had a quiz where the range was 20 to 100. So you want to look at the spread, and one of the measures can be the range, and the range does give helpful information. The other measure of center is the interquartile range. You want to use this if the data is skewed. We use this if the data is skewed, and we recently learned this. This is IQR equals quartile 3 minus quartile 1. And now let's go back to our quiz score example. So let's say this is your last quiz. This is a score of 50. 60, 70, 80, 90, 100. And most of you guys scored here. So range would be a good one to use. Range would be fine here. We would say that the range is 70 to 100 or 30. But that test that I had where the lower score was a 20, so that would look like this. Range would not be a good measure of spread in this case. And this is what that quiz looked like. Most of you guys had scored from 70 to 100, and then I had one student who hardly ever comes take the test and got 20 out of 100 because he had no idea what he was doing. Well, does the range really describe this data set? Because the range on this one would be 20 to 100 or 80. In this case, you can see that if this is truly my data set and I just have one outlier out here, I don't want to use range because that's not reflective of what my data actually looks like. I need something else to measure the spread of this data. So what I would use instead is that interquartile range. And remember, interquartile range is that middle 50% of the data. So notice no very small values on the left and no very large values on the right are going to affect my range. I'm just going to look at where the middle 50% is, and if your data is skewed, most of your data will be in the middle 50% and a little bit of your data will be skewed in one direction. So in this case, we could say that the range is, the interquartile range is like 80 to 90. And 80 to 90 would be a much better description of spread than 20 to 100 for this particular distribution. So it's the same with skew. Remember, when we have skew, it's like that gradual skew. In either case, if we're talking about spread of data, we don't want to use the minimum value and the maximum value. Because if you'll notice, most of your data is right here. This would be Q1 and this would be Q3. So you don't want to use this large spread to describe your data when most of your data is over here to the left-hand side. And it's similar for this. Your maximum might be here and your minimum over here, but you don't want to use this as the description of spread because most of your data is here and you just have some skew to the right. So our first two measures of range are, not range, sorry, that is a huge mistake. Our first two measures of spread are the range, which is your extremes, the max or the min. But if you have a skewed data set, we need something else. So that would be your interquartile range, which is your third quartile to your first quartile. Now, the one last way that you can measure spread, and it is probably the best description of spread, is standard deviation. And standard deviation describes the variation around the mean or the variation around your typical observation. Now this guy, he is complicado or complicated. That's why I have my little complicated avocado here. He's actually kind of a mad avocado. Maybe he's mad because he's so complicated. But this idea of standard deviation, that we need to go much more in depth because it is a measure of spread that takes into consideration every single data value, much like the mean takes into consideration every single data value. So for now, what we're going to focus on is the two easier ones. And we're going to save this complicado standard deviation for a little bit later. So just like with every other element of a distribution, we have some graphs here to help us have a quick reference for what we are going to use. So in these left ones, you would use range. Range in this case would be a good description of the spread. So range here would be a good description of the spread. These, it would not. Most of your data is right here, and some of your data is over here. So same with this one. Most of our data is, I don't know, I would say about there, and then some of your data is to the right. So in this case, you use IQR for spread. So outliers and skew are going to affect your range. But IQR is resistant to skew and outliers. And then I'm going to highlight that for myself. Oh man, I didn't want that color. I wanted this color. Dang it. Mistakes were made, family. Guess it doesn't matter all that much. And then the one last thing that I want to mention on range is this. And let's look at this histogram right here. We would say the data varies from 40 to 140. And the key word here is the word varies. You never say, never, 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 ever, ever, the data ranges from 40 to 140. Never say data ranges from 40 to 140. You will lose points. You will not get full credit if you use the word range, because range is very specifically the distance between your minimum and your maximum. So you never want to say the data ranges from 40 to 140. You want to say the data varies from 40 to 140. So I will zoom out now, and hopefully the format of this card stock makes sense now. This side of the card stock is the detailed overview of how to describe a distribution. And this side of the card stock is the quick reference. When you guys come back, you're going to put this in a sheet protector because we're going to refer to this throughout the year. You will use or face up the one that makes the most sense to you, but this is your detailed description. This is your quick reference guide as you're going through your can you do's and problems in class, that you can just hopefully quickly look at the picture and remind yourself what the description is. Now, before we end, I just want to show you a couple of distributions, and I want you to decide what their shape is. So here's our first one, and I'm going to go pretty quick. If you think you need more than like 10 seconds, pause the video. Shape on this guy, roughly symmetric. This guy would be roughly symmetric. I could understand if you thought bimodal. I think that you would get full credit if you said bimodal, because you kind of have a peak here and a peak here. But I think for me, I might say that this guy is roughly symmetric. Outliers. I don't think that there are any outliers. Spread, would you use range or IQR? I would use range. And center, would you use mean or would you use median? I would use mean. Okay, this guy, shape. Right skewed. Outliers. No, I do not think that this is an outlier because the distribution is skewed. What would you use for center? The median. What would you use for spread? IQR. Okay, teacher shoe data. Well, this one's an easy one. Right skewed. Definitely outliers. We would use median for the typical observation, and we would use IQR for the spread. We definitely wouldn't want to use range on this for the spread because most teachers own between 0 and 20. So we don't really, a range of 80 is not going to be accurate when most teachers have between 0 and 20 shoes. I think that that's probably good. This one is a really good example of a roughly symmetric distribution. This guy, even though you have your outlier here, I would say he's roughly symmetric. This guy, definite right skew. So, hopefully when we actually put this all together and now write our written responses for the description of a distribution, this sheet is going to help you quite a bit. Okay, that's it, guys. Love ya.